All right, welcome to our last topic. Our last topic is still dealing with both scientific notation that we learned in topic 4 and our exponent rules. All right, so we got to keep in mind both of the rules for our exponents and also just regular old scientific notation and multiplying rules. All right, so let's look first at our problem. It's 4.3 times 10 to the fourth times 2 times 10 to the second. So our first step is we want to multiply our bases. So we're going to multiply our bases. So we're going to multiply 4.3 and 2.0, and you're going to write down whatever answer it is. Now, we're going to follow our next step, which is to add our exponents. Remember, 10 to the fourth and 10 to the second both have the same base, so we can apply this rule. So 4 plus 2 becomes 6. Now we're going to write our whole answer all together, and it's 8.6 times 10 to the sixth. Now you do have to make sure that when you multiply, you only have a number that's your decimal point only has one number in front of it. All right, if not, at the last step, you kind of have to rechange it. All right, so let's try some practice problems. All right, so first off, we have to multiply. So when I multiply 5.3 times 2, I'm going to get 10.6. And now when we multiply 10, or excuse me, add our exponents, 4 plus 2 is 6. Now this is not scientific notation. Remember, scientific notation only has one number in front of the decimal point. So here we are, we're going to move once over, so 1.06 times 10, and since we moved left, we're going to add another number times the seventh to the seventh power. If I moved right, it would become the fifth. All right, let's try another one. 2.1 times 2 becomes 4.2 times 10. 3 plus 1 is 4. This is written in scientific notation, so I'm good to go. Our next one. 3.22 times 8.12, and that's going to be 26 and 1464 times 10 to the ninth, because 2 plus 7 is 9. Unfortunately, this one is not written in scientific notation. So again, we've got to move the decimal point over once. So our new number is 2.6464. And again, you could round this number too to maybe the tenths or the hundredths, but I'm going to keep it here. And since we moved left, I'm going to add an extra place onto my scientific notation. Let's try another one. We have 7.9905 when I multiply my two bases together times 10. 3 plus 7 is 10. So again, I have to move my decimal point over, so 3.79905 times 10 to the 11th power. If I moved right, it would become the 9th power. All right, let's work with our division now. So here, we want to simplify our rules. So remember, 2 divided by 4 is going to be 1/2. And following our exponents, 7 minus 3 is 4. All right, you can also keep that as a decimal too. You can have 0.5 times 10 to the fourth. And again, are we written in scientific notation? Nope. I've got to move to the right once, so 5 times 10 to the third power since I moved to the right. Okay, let's continue. Now we're going to have 8 times 10 to the 7th divided by 8 times 10 to the 8th. So remember, we're going to simplify our whole numbers, our bases of our scientific notation. So 8 divided by 8 is going to be 1. And we're going to do times 10, and we're going to subtract our exponents. 7 minus 8 becomes -1. Over here, 4 divided by 12 is going to become 1/3 times 10 to the fourth power. Now, since 1/3 kind of repeats itself, I'm just going to write it to the 10th. Okay, times 10 to the fourth, and we have to move it right once times, so this is going to come about 10 to the third power. Okay, now on to everybody's favorite thing, Word problems. Okay, so here we are. We're going to assume that there are 20,000 runners in New York City Marathon. Each runner runs a distance of 26 miles. If you add together the total number of miles for all the runners, how many times around the globe could the marathon runners have gone? Consider the circumference of the Earth to be about 2.5 times 10 to the fourth. So our first step is we have to figure out how far do these runners run. So we have 20,000 runners. And a marathon is about 26 miles. It's a little bit longer, actually, times 26. So those marathoners, all together, they can run 520,000 miles. That's pretty far. Okay, so we want to figure out how many times this number can fit into my circumference. So first, let's make this into scientific notation. So 5.2 times 10, and remember, 1, 2, 3, 4, 5, 10 to the fifth, divided by 2.5 times 10 to the fourth. And when we divide this out, we're going to have 2.08 times 10 to the first power. So if we move it over once, they can do 20.8 times. That's pretty far, 28 times around the globe. I don't think I could run that far. All right, next one. The light travels at a speed of 1.86 times 10 to the fifth miles per second. So that's pretty fast. It takes me about 7 minutes to run a mile, so not even in seconds. And that's a very good mile time when I was younger. But all right, if a light year is a distance that travels in 1 year, how many miles are in a light year? So first we have to figure out this miles per second and get it into miles per year. So first we're going to do 60 seconds times 60 minutes. Figure out how many minutes are in a second. Then once I get that, I have to figure out how many minutes are in a day. So, which is also equals the hours. So 24 hours. And now now we're at days. So now we have to figure out in a year. So there's 365 days. So that is 3. So there are 31,536,000 seconds in a year. So since that's such a huge number, we're going to write this as scientific notation. So I'm going to write 3.1536 times 10 to the 7th power. Okay, so I want to know, so this is for 1 in a year. So now I want to figure out how far it can go each time. So I'm going to multiply that, 1.86 times 10 to the fifth. And my answer is going to be a pretty big number, and I'm only going to write the first 3 digits. 5.87 times 10 to the 12th miles in a year. So light is traveling very, 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 very far, if you want to write that out into standard form, in a year. All right. Our next step is we have a little table over here. This one also has to work with a lot of comparing. Remember, when we compare, we're going to first look at the exponent. Then, if they're both the same, if they are the same, look at the base. Okay, so here we go. Which state has the largest population? So we want to look in the column that has population. So remember, we want to look for the largest exponent first. So that has a 7, that has a 7, that has a 7. So right now we're between the states of Texas, Pennsylvania, and California. Next, we're going to look at the base. So we have 1.8, 1.2, and 3.1. So what would be the largest number here? That's right, California. Okay, now we want to look at the smallest number. So again, we'll look at the smallest, all right, for population. And we want to look which one has the smallest exponent. So I just have 5, so that's got to be the smallest. So Vermont, VT is Vermont's shortcut. All right, now same thing over here. We're going to look at which one made the most amount of calls. So let's look at the calls. All right, again, we want to look at the exponent first. So we have 10 is the largest. I see 10. Okay, so we're down to our same states, and now we want to look at the bases. We have 3.9, I have 1.9, and 5.6. So which out of these three numbers is the largest? That's right, California again with 5.6. All right, finally, we're going to see which states made the least amount of calls. Okay, so the least amount of calls, again, we're looking at the calls column, and we want to look at the exponent with the smallest. Oh, 8 seems to be our only one, and so Vermont again. So our next step is how many calls did Texas, Pennsylvania, and California make all together? So this one we're going to be doing adding exponents, and this trick for adding exponents that I'm going to show you only works when all the exponents are the same. So Texas is 3.9 times 10 to the 10th power. All right, so that was Texas. PA is 1.9 times 10 to the 10th. And finally, California is 5.6 times 10 to the 10th. And we're going to add all these up. And since they're all the same exponent, we're going to keep them the same. Okay? And then we're just going to add up our decimal points. So 9 and 9 plus 6, so 24. Carry the 2, bring the decimal point off. 2 plus 3 is 5. 5 plus 5 is 10. 10 plus 1 is 11. Okay? But 11.4 times 10 to the second, or sorry, 10th, is not written in scientific notation. So we need to move my decimal point over once. So it becomes 1.14 times 10. And since I moved left, I'm going to increase that number to make it 11. All right. Again, for the last time, you're going to be filling out your summary. Okay, think about a scenario where you think you might use this. Okay, a question, and then your practice questions. Good luck. Good luck.